Hello student, let's try to understand defects of vision and their correction. Sometimes the eye may gradually lose its power of accommodation. In such cases, the person cannot see the object distinctly and comfortably. The vision becomes blurred due to the refractive defects of the eye. There are mainly three common refractive index. These are myopic, nearsightedness, hypermetropia, farsightedness, presbyopia. These defects can be corrected by the use of suitable spherical lenses we discuss below. So first one is myopia. Myopia is also known as nearsightedness. A person with myopia can see the nearby object clearly but cannot see the distance object distinctly. A person with this defect has the far point nearer than the infinity. Such a person may see clearly up to distance of few meters. In a myopic eye, the image of the distance object is formed in front of the retina and not at the retina itself. This defect may arise due to the excessive curvature of the eye, elongation of eyeball. These defects can be corrected by using a concave lens of suitable power. This is illustrated here. A concave lens of suitable power will bring image back on the retina and this defect is corrected. So this is what is called student myopia. Now let us do the hypermetropia. Hypermetropia, also known as farsightedness. A person with hypermetropia can see the distant object clearly but cannot see the nearby object distinctly. The near point for the person is farther away from the normal point. Such a person has to keep the reading material much beyond 25 centimeter, the eye for the comfortable reading. This is because the eye rays from the closely close by object are focused at a point behind the retina as shown it. This defect arises either because the focal length of the eye lens is too long, the eyeball has become too small. This defect can be corrected by using convex lens of appropriate power. This is illustrated. Eyeglasses with a converging lens provide the additional focusing power required for the forming the image on retina. Presbyopia. The power of accommodation of eye usually decreases with aging for most of the people. The near point gradually recedes. This find it difficult to see nearby object comfortably and distinctly without corrective eyeglass. This defect is called presbyopia. This defect is called presbyopia. It arises due to gradual weakening of ciliary muscle and diminishing flexibility of eye lens. You read this one, student. NCRT. This is the presbyopia. What we can do. The power of accommodation eye usually decreases with aging. For most people, the near point gradually recedes. They find it difficult to see the nearby object comfortably and distinctly without corrective eyeglass. This defect called presbyopia. It arises due to gradual weakening of ciliary muscle and diminishing flexibility of eye lens. Sometimes person may suffer from both myopia and hypermetropia. Such people often require bifocal length. Common type of bifocal lens consists of both concave and convex lens. The upper portion consists of the concave lens. It facilitates distant vision. The lower part convex lens. It facilitates near vision. These days, it is possible to correct the refractive defects with contact lens through the surgical invention. This is the presbyopia. Refraction of light through glass prism. You have learnt how light get refracted through the rectangular glass slab for the parallel reflecting surface. In a glass slab, the emergent rays is parallel to the incident rays, however it is slightly displaced laterally. How would you how would light get refracted through the transparent medium? Consider a triangular glass rim. It has two triangular bases and three rectangular lateral surfaces. These surfaces are inclined to each other. The angle between its two lateral surfaces is called the angle of prism. Let us now do an activity to study the refraction of light through the triangular glass prism. Here P is the incident, EF is the refracted rays, and Fs is the emergent rays. You may note that the ray of light entering from air to glass at the first surface AB, the light rays refracted and bent towards the normal. At the second surface AC, the light rays has entered from the glass to air. Hence, it is bent away from normal. Compare the angle of the incident and angle of refraction each refracting surface of the prism. In this to similar to the kind of bending that occurs in the glass slab. The peculiar shape of the prism makes the emergent rays bend at an angle of direction of the incident rays. This angle is called angle of deviation. In this case, D is the angle of deviation. Mark the angle of deviation in the above activity.